formula used to find the distance around a circular object. We already talked about this. We know it's pi d and also 2 pi r. We also know that the circumference of a circle is going to be of radius 1, 6.28. Of a semicircle or a half circle, it's going to be what? Half, that's what, folks?
3.14.
3.14. Okay? Now, a directed angle. A directed angle is going to be an angle. Yeah, I want you to draw these. Are you ready? Here's the end point. Here's the arrow. Here's the end sign. And this tells you the direction that it's opening. That is a directed angle. You can see the arrow on the inside telling you which direction it opens. This is opening counterclockwise. Go home. Same thing here, except for this one is now going to be opened in which direction? Clockwise. Okay, did you highlight the ones that are missing? Yeah. Oh, good girl. Thank you.
She's on upside down.
You don't have to be her family. That makes me very happy.
Just because she's family doesn't mean you have to be it.
Thank you. Okay, that is a directed angle. We have two different types of directed angle. Okay, a counterclockwise and a clockwise. Clockwise angles are positive angles. I meant counterclockwise angles are going to be positive angles. And clockwise angles are going to be negative angles. Okay? Counterclockwise, positive. Clockwise, negative. Do we understand whenever I say clockwise?
Yes, the way the hand goes on the clock.
Okay, I want to make sure. Well, some of you were kind of looking at me like I was nuts there for a minute. And, you know, I do get that reaction often. Now, with that said, we have a terminal side and we have an initial side. Now, I'm going to draw this at one time. Are you ready? Here's going to be the center. This is what we call the initial side. The initial side is the side that doesn't move. Do you understand that? Then we have the terminal side. This is going to be the ray of the angle that does move. And it terminates, meaning it moves, and then terminating means it stops moving. Does everybody understand that? Now, the next thing you need to worry about are what we call coterminal angles. I love coterminal angles. I love them. They're so special. A coterminal angle says that there are two angles that exist from just one lovely directed angle. Why is that? Because you can open that angle clockwise and you can open that angle counterclockwise, which means that they share the same initial side and the same terminal side. Now, what I want you to understand is that we have this one angle right here. Where am I floating?
1 minus 360.
Wait, so what was the difference between a directed angle and a coterminal angle?
A directed angle gives you one angle in the direction that it's opening up. Okay? Coterminal angles are going to be two angles that come from one angle, depending upon the direction that it opens up. For example, this is one angle. However, I have the red positive directed angle, which means it has the initial side at the bottom and the terminating side to be here on the left. And then I have the negative angle that's opening up the bigger obtuse angle. What's obtuse? Bigger than 90. Do you understand that? I have the obtuse angle that's going to be opening clockwise. That gives you the negative angle. Do you understand that? Yes or no? Okay? Standard position is whenever the initial side is on the positive x-axis. You can take an angle and you can put it anywhere you want. Anywhere you want. Okay? But to be in standard position, the initial side of that angle must be on the positive x-axis. The terminal side can go anywhere you want.
What if it starts on negative and goes positive?
Is the initial side on the positive x-axis.
No. Part of it.
The initial side must be on the positive x-axis for it to be standard position. You can mix hairs and split hairs all you want here. It doesn't matter. Okay? If it's not on the positive x-axis, it's not standard position. Now, the next thing we got going on here is we have a radian. Now, everybody get their books open to page 249? We have them? Now, in the middle of page 249, at the second diagram there, it gives you your radian measures. Do we see that? The top picture gives you 1 radian. If you go to this middle one, it gives you all 6 radians with that little sliver left over. Do we see that? Yes or no? It looks like a bicycle wheel, the spokes on it. Yes? Do we see it?
Yeah.
Okay? That is going to be your concept of a radian. A radian, 1 radian, what angle do you think that 1 radian represents there at the very top of page 249? What measurement do you think that is?
Half of,
50 degrees.
35.
I would say it's more than 45. Okay? A bigger chunk of that than 45. Probably about a 60 to a 55 degree angle is what we're looking at there. Okay? Now, anytime that you have a pi in the angle, it's a radian measure. Anytime you have pi in the angle, it's a radian measure. Now, your textbook sometimes will put a little r as an exponent above the pi. That little r tells you that it is radian measure. Do we understand that? Yes or no? Now, another way of measuring is degrees. For example, 45 degrees, that little circle. It's no different than our measuring system. It's Fahrenheit versus Celsius. Our temperature in Fahrenheit is 98.6 degrees. Nursing students, what's the temperature in Celsius? Come on, what is it? I don't know. Isn't it like 37 degrees or something like that? Yeah, here we go. Okay, the point is they're the same unit, correct? They're the same degree, the same temperature. They're just a different measuring system. You get that? Same concept here. Now, how do you convert? If I'm giving you a 45-degree angle and I want that degrees to go away and be converted to a radian measure, you have to divide by what you want to get rid of. Well, what do we want to get rid of is degrees. So I divide by 180 degrees. If I wanted to get rid of my radian measures, I'd have to divide by what signified radians? R, but if there's something in that, I know it's radians.
Pi.
If there's pi, I want to divide by pi. Now, why in the world am I using pi over 180? Someone please talk to me about that.
180 is half the circle.
Oh, so what you're telling me is, I have this circle, and if I have half of that, right? You told me that the circumference of the circle was 2 pi, right? And somebody else already told me that there was how many degrees in the circle? 360 degrees. So you're telling me that 2 pi is the same thing as 360 degrees. Yes? That's what you're telling me. Then you're telling me that half of that would be a semicircle, which is pi, and half of 360 would be 180. Is that true? Yes or no? Are we good so far? Which means, how many different ways can I write the value 1? Well, 1 can be 5 over 5. It can be pi over pi. It can be 180 over 180. Or it could be 180 over pi. Or it could be pi over 180. I made it up just so that you could see. It could be anything you want. There's infinitely many different ways to write 1, correct? Now what we're doing is we're converting one measurement into another measurement. So we have to multiply that measurement by a unit of 1. Because when you multiply something by 1, what do you always get back? Itself, right? You're not changing it, you're just changing the view of it. Yes.
How can 180 over pi be 1?
How can 180 over pi be 1? Well, isn't 180 equal to pi? So if pi and 180 are the same, can I put a pi in for 180? Can I put a 180 in for pi where I want to?
Yeah.
It's basically saying 180 equals 300.
Okay, there are degrees. Degrees. We're talking measurement. Whenever you use pi, it's literally taking it and putting it on the XY axis. Okay? That's a measurement. You can visibly see it. Degrees is not a measurement. Okay? You're comparing different concepts. Okay? What you need to understand is that it's a substitution concept. X is equal to y. Well, it doesn't matter what x is. It doesn't matter what y is. What matters is every time you see an x, you can plug in a what? A y. You can understand that. Okay? Does everybody understand that? Pi, yes, it's 3.14. And yes, it is a measurement that you can plot on your XY axis. Okay? 360 degrees and 180 degrees. Degrees is not something you can plot on your axis. You have to transfer those into radians to be able to plot them. Do we all understand this? Okay? Now, so we are using these two concepts right here. So if I give you 45 degrees, I have to multiply that by a value of 1. And I want to change 45 degrees into a radian measure. So how do I do that? What do I want to multiply by? What do I want to get rid of? The degrees. So I need to change that 1 into be a pi over 180. Why? Because I want the degrees to go both sides. Yes? So, I have 45 pi over 180, and if you reduce that fraction, it's going to give you pi over 4. Do we see that? Why? Because half of 180 is 90, half of 90 is 45. So there are 4 45-degree angles in 180, right? Now what this means is 45 degrees is equivalent to the radian measure of pi over 4. In other words, that r tells you that it's what? A radian. Yes or no? Did you get that? Another thing would be 30 degrees. Let's take 30 degrees and transfer that into radians. Well, I'm going to multiply by what to get rid of that degrees? I'm sorry? Multiply by 1, but what does 1 turn into? Pi over 180. So what I have is 30 pi is equal over 180. The zeros cancel out. I have 3 pi over 18 to give you pi over 6. Pi over 6 is the same thing as 30 degrees. All it is reducing fractions. All it is reducing fractions. You see that?
So a pi over 6 is 30 degrees?
Pi over 6 is 30 degrees. Now, let's say I give you 2 pi over 3. And I want to know what degree 2 pi over 3 represents. So how do I put this into a degree now? Well, what do I want to cancel out? I want to cancel out the pi, so the pi goes to the bottom, and what goes on top? The 180. So now I'm going to have pi's cancel out, and this is going to be 2 times 180 divided by 3. What's 180 divided by 3? 60. So that's 2 times 60 to give you 120. So what I'm telling you is that 2 pi over 3 is the equivalent to 120 degrees. Do you understand that, yes or no?
How do you know that stuff?
How do I know what?
That pi over 6 equals 30 or 2 pi over 3?
Because we just converted using multiplying by 1. Using the ratio that 180 is equal to pi.
Oh, so this whole thing is the answer.
Yeah,
You want to feel like that, though, like divide before we multiply.
I don't care. Now, why am I showing you guys this stuff? Because what you have to do is eventually you are going to memorize and have a test over this, and this is going to be a 76-point test that will have to be done within 20 minutes.
Got his death on the smartphone.
You have to be able to do your unit circle with all the degrees, the radians, the sine and cosine values, the quadrants, the tangents, and
What was that space? 40 and now graduating.
sine, cosine, quadrants.
I'm gonna have to make an idea.
Memorize
I'm
it.
gonna have to make an idea.
Well, like
Okay, quiet. This is about 82 points, I think.
Oh my
82 points. Okay. Now I want to make this very, very clear. It is not difficult at all. Who in here has memorized this before already? Okay. It was not difficult, was it? It's literally going around the circle and counting. That's all it is. It's counting and reducing. And I'll show you how to do that tomorrow, and we'll develop the circle together.
Just kind of.
This is our next week. Next week.
Okay.
Okay? The test will be next week over this stuff. Now,
Do we write these?
yes. Wait. That's not what I want. On that. Compliment. What's compliment? No, it's not so.
Well,
something
technically,
that
that's
makes me feel better. I'm sorry? Two angles add together to give you 90 degrees. What's supplement? Two angles add together to give you 180 degrees. Do we see that, yes or no? If you don't remember it, you better write it down. This should be stuff that you all remember. However, I already know that many of you are sitting here saying, I don't remember.
So you can compliment a 90-year-old, you give supplements to a 16-year-old.
Stupid.
Whatever.
Or an 18-year-old with 0. Easy stage. If you can remember it.
What's underneath the 180?
We have to back up. I missed the slide.
Good.
Cool.
I know.
So I gotta write that down too. Or that on the front.
Okay, coterminal angles. You have to write this down. I don't think it's on there.
Can I put it on the
Coterminal angles. Find these by adding or subtracting 2 pi every time with a given angle. To find coterminal angles, you're going to add or subtract 2 pi depending upon the given angle. What's coterminal angles again?
They can go forward, back, both sides.
Coterminal angles.
Say,
Angles with the same initial terminal side. So if I'm talking about coterminal angles, that means you can have infinitely many positive, you can have infinitely many negative coterminal angles. Okay? But what does that mean just now?
Couldn't even what you were saying.
Okay, you guys are clearly not paying attention to what you're writing. Story of my life.
that's how I like. I do a lot better.
Don't talk. You can't focus.
Does it make sense to say that I'm lost, but I know what's going on at the same time?
No.
I'm just hoping that this is like a simple. If you know the formulas, that's fine. I hated that.
If they hate it, I might as well.
So we have to, and we're going to.
We're going to be doing trigonometry, yes.
That's fine, guys.
Well, that might not.
Are we ready? Okay. Now, I want you to envision a bicycle wheel. Does everybody have it in their head?
Yes.
Steering wheel. Everybody have it in their head? If you're driving either one, it's a wheel, okay? Put your hand at 3 on the steering wheel. Go 180 degrees.
Wait, I turn. What if I'm turning left or right? Which one?
Left. Left, 180 degrees. Now go another 180 degrees, still left. Put you where?
Back at 3.
Back at 3, right? Now, go another 360. That's a coterminal angle. Do we understand that? Do we understand that? Go another 360 degrees.
40 and all that would be.
Those are all coterminal angles. Does everybody understand that? So every time you add 360 degrees, you're finding a coterminal angle. Because it has the same initial side, the same terminal side. Every time. You understand that? So, if I say find a positive and a negative coterminal angle of pi over 5. First of all, what unit of measurement am I in? Radians. How did I know it's radians? Because of the pi. I knew I'm in radians because of the pi. What I have to simply do here is take pi over 5 and add 2 pi. Take pi over 5 and subtract 2 pi. Why am I adding 2 pi and subtracting 2 pi?
I know where you go.
Because what did I tell you about the direction?
Yeah, you're negative.
If you go clockwise, that is a negative angle. If you go counterclockwise, that's a positive angle. Do we understand that? So in order to do this, I'm simply going to put this over 1, and I'm going to take pi over 5. What's my common denominator between 5 and 1? 5 5, so this is going to become 10 pi over 5, and that gives you 11 pi over 5. There's my positive coterminal angle. How do I find my negative coterminal angle? Put it over 1, pi over 5, minus 10 pi over 5, to give you negative 9 over 5. What?
But we're good. Alright. Where'd the 5 come from on the bottom?
I need a common denominator. You need a common denominator between 1 and 5.
We make the 6 of
They
it.
stay
Cut
calm.
your freaking head off.
Your head is like,
Like somebody sitting there.
Oh.
How do you get 9?
not here, but she's coming. Okay, now, here's my positive coterminal angle. Here's my negative coterminal angle.
How do you get 9?
How do I get 9? Well, what's 1 minus 10?
Oh, okay.
It's okay, we all hate fractions, you can clearly tell this. Now,
I was thinking
same exact concept here, I just showed you the first theory, you don't have to write it down here.
vegetable.
I like Chinese.
It
does
vegetable
too.
soup.
Do you understand where 2 pi came from? Why I'm adding, subtracting?
Or even where pi over 5 comes from.
Pi over 5 is a generic angle, I pulled out a generic. Okay? Why is 2 pi? Because what I want to know is I want a coterminal and an angle square. Coterminal means has the same starting and ending point. In order to get that, all I have to do is go around the circle 1 time to get that.
Is that what you do when you're driving?
Dude,
Coterminal.
it's always gonna be that.
Oh, this is positive angle.
Pi is always gonna equal 1.
She's going down the road. I'll make you.
Radius.
No matter what degree it is.
Coterminal just simply says you're either adding, if I'm in radian measure, pi it.
Coterminal.
If I'm in radian measure, you add 2 pi or subtract 2 pi. If I'm degree measure, if you are in degree measure, what are you gonna do?
We're gonna find the.
Add
Correct.
360 or subtract 360. Why am I adding 360 or subtracting 360?
Because mechanical.
Because 2 pi is equivalent to
36.
360.
Is that a home?
Alright, tonight for homework.
No.
2 through 34 even.
I got a basketball.
2 through 34 even. It's your homework. Your homework.
Would you like 2 through 20?
2 through 34 even. Notice they're even because my little cheaters.
I'm sorry. I apologize and I redid it.
Yes, you did.